Welcome viewers. In this video we will see the number base conversion. In this number base conversion there are three types available. First we will see the integral type. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the topic integral part. So the integral part, in the number base system we have four different number base available: decimal, binary, octal and hexadecimal. So in this integral part we are going to see decimal to binary, decimal to octal, decimal to hexadecimal. Right? The decimal is converted into other three base: decimal to binary, decimal to octal, decimal to hexadecimal. First we will see the decimal to binary, how to convert decimal to binary. We will see the example 1. 21 base 10 means it is a decimal number. We need to convert into binary number with base 10, base 2. Right? How to convert this decimal number 21 into binary? It is an integral type. It is, we need to divide by 2. The given decimal number should be divided by 2. We need to find what is the remainder. Right? So the 21 is divided by 2. At that time it is goes 10 times. The balance is 1. Again divide by 2, it goes 5 times. The balance is 1. Again divide by 2, it goes 2 times. 5 is going to 2 times, the balance is 1. Again divide by 2, it goes 1 time, the balance is 0. Now we need to write this digit in this reverse order: 1 0 1 0 1 1 0 1 0 1. So this n refers the LSB, least significant bit. This n refers the MSB, most significant bit. Right? Now the 21 is converted into binary. The binary equivalent is 1 0 1 0 1. How we are converted? The 21 is divided by 2 continuously. In each and every stage we calculated the remainder, whether remainder is 1 or 0. These all remainders are written in a reverse order: 1 0 1 0 1, so that this 21, the decimal number 21 with base 10, is converted into binary number 1 0 1 0 1. The base is 2. Right? So now we'll go to the second example. 53.625 is converted. We need to convert 53.625 into the decimal number. Decimal number 53.625 should be converted into binary. Right? So here the whole number available and the decimal digits are decimal also available, 0.625. Right? First we will convert 53. Then we will convert 0.625. There is separate two different process. First we will convert the whole number 53, as like very similar to the previous case. The 53 is divided by 2. So what happened? It is goes 26 times. 26 into 2, 52. The balance is 1. It is 26 again divided by 2. It is goes 13 times. There is no balance. Balance is 0. Again the 13 is divided by 2, it is goes 6 times, but balance is available 1. Again it is divided by 2, it goes 3 times, balance is 0. Again it is divided by 2, it goes 1 time, the balance is 1. So what is the number? 1 1 0 1 0 1. Right? That is available, 1 1 0 1 0 1. This 53 is equivalent to the binary is this number. Now we need to convert this 0.625. How will you convert this 0.625? 0.625 is multiplied by 2. Here we divided, here we need to multiply. So while multiplying, it is 1.25. So write this first digit separately. 1.25, one is wrote separately. What is the balance? 0.25. So this 0.25 again multiplied by 2. It is 0.5. 0.5 means we have only 0. Right? Again this 0.5 is multiplied by 2, it is 1. So we will take this one in the separate. We need to write this one separately. You can go with n numbers. Normally we can go up to 3 or 4 digits are enough. It can go up to n numbers. There is no limitation. Right? So what we need to do, the given number should be multiplied by 2. The first digit is written separately. Either 1 or 0 will come. The balance in this 1.25, 1 is written, 1 is stored here. 0.25 is again multiplied. They will get 0.5. In this 0.5, 0 we retained here. The 0.5 is multiplied by again 2. Right? So the process will continue. So here we need to write in a downward order: 1 0 1. Here we wrote in the upward order, reverse order. Here we need to write in this downward order, 1 0 1. So the binary equivalent of 0.625 is 101, right? So in this example 2, we discuss how to convert the decimal number having the digits, having the points, 0.625, right? So how to convert this 53 converted as a normal, as very similar to the previous case. This 0.625 is converted by multiplying with the 2. But we need to write the first digit, the remainings are again multiplied. Now we'll go to the third example, 112, 112. The decimal number 112 should be converted into binary, right? So very simple, 112 should be divided by 2. So it goes 56 times, balance 0. Again divided by 2, 28 times, balance 0. Again divided by 2, 14 times, balance 0. Again divided by 2, 7 times, balance 0. Again divided by 2, 3 times, balance is 1. Again divided by 2, these 3. This goes 1 time and balance is 1. So we need to write in a reverse order, 1 1 1 0 0 0 0. So the binary equivalent of 112 is nothing but 111 00 00. That is 1 1 1 0 0 0 0. Right. Now we'll go to the fourth example. So in the fourth example, again we have decimal numbers are available, 124.8125, right? So first we will convert this 124 as a normal procedure. 124 should be divided by 2. So it goes 62 times, balance 0. 62 is again divided by 2. 31 times, balance 0. 31 is again divided by 2. 15 times, but the balance is available 1. 15 is again divided by 2. 7 times, the balance is 1. This 7 is again divided by 2. 3 times, balance is 1. 3 is divided by 2, thus it goes 1 time and balance is 1. Now we need to write the digits in this reverse order, 1 1 1 1 1 0 0, right? 1 1 1 1 1 0 0, right? Now 124 is converted into binary. Now we need to convert 0.8125 into binary. What we need to do for decimal points? It should be multiplied by 2. 0.8125 is multiplied by 2. It is nothing but 1.6250. So in that 1 is written separately. The balance 0.625 is again multiplied by 2. So what we got? 1.25. 1 is written separately. This 0.25 is again multiplied. 0.25 into 2 means 0.5. There is no digit available. So we wrote 0. This 0.5 is again multiplied by 2. It is 1. So 1 is written here. The balance is 0. 0 into 2, 0, again 0. So it is finally we got one more 0. So it should be written in a reverse order, downward order, 1 1 0 1 0, right? So the binary equivalent of the decimal equivalent of 0.825 is nothing but 11010, right? How we done? This decimal point is multiplied by 2 and first digit is written separately. The remaining digits are multiplied again and again, so that we got this digit. There is no endless. We can go n number of multiplication, but normally we'll go for 3 to 4 digits, right? Now both 124 and 0.821 is converted into binary. 124 normal division, 0.825 multiplication, right? Now we'll converted this decimal number into binary. So we discussed 4 example in the decimal to binary system. Now we'll go to the decimal to octal system, converting